Let me hit record on the meeting. So why don't we start here? Let's look at, so these are from homework number 8. And we're going to go over 2 problems, number 16. All right, and let me bring that up right now. So number 16. So we all have it in front of us is, there we go. It's this problem right here, okay? All right, so it says for the clinical trials of a weight loss drug containing Garcinia cambogia, the subjects were randomly divided into 2 groups. The first received, excuse me. Excuse me. The first received an inert pill, so I'm assuming that's some kind of a placebo, right? And with an exercise and diet plan. While the second received the test medicine along with the same exercise and diet plan. The patients do not know which group they are in, nor do the fitness and nutrition advisors. Which is the treatment group? So then they ask for a few questions, A, B, C, and D. Which is the treatment group? Which is the control, if there is one? Is this study blind, double blind, or neither? Is this best described as an experiment, a controlled experiment, or a placebo-controlled experiment? Okay, so now let's kind of decipher all of these here. I think for, let's start with A. So here. All right, the treatment group. So again here, what are they, if we look at this question here, we say, all right, there are clinical trials for the weight loss drug, right? So the treatment group is gonna be the group that receives the test medicine. Right, not the inert part. So if we look here, we look at, all right, while the second group received the test medicine along with the same exercise and diet plan. So here, let's use the same color. So that would be the treatment group. All right, now if we look at B, it says which is the control group, if there is one, right? Now in this case, there is a control group, right? The control group is the group that receives the inert pill. I assume that inert means it really is not gonna do anything. Right, it's some kind of sugar pill, right? When we say inert, think of a placebo. Right, let me highlight that with a different color here. So, okay, notice that both of those receive the same exercise and diet plan, so that's not changing. Really, the only thing they are going to test is that inert pill. Okay, all right, and that would be this one there. Okay, any questions so far on this homework problem? Okay, again, same as a couple weeks ago. Feel free to chime in on the chat or unmute yourself and just say your question out loud. It'll be just as effective. Okay. All right. So there's no questions on A or B. Let's take a look at part C. All right. Distortion in my audio. Okay. It might be just a, well, the connection seems to be okay. All right, I'll try to get closer to the mic. Maybe, let me see here. All right, is this a little better, Jorge? Okay, so now let's move along here to part C. Okay, so it seems like, okay, so now we're all good here. So part C is this study blind, double blind, or neither? All right, now remember, just a reminder of what blind means is when one of the groups does not know which group they belong, right? Now, if we look at the problem, that the way it's posed to us, we can find that in the last part of the question, right? Now here, okay. So here let me read that aloud again. The patients do not know which group they are in, nor do the fitness and nutrition advisors. So it's definitely blind, but is it blind or double blind based off that last question? Anybody, any guesses on what should be the answer here for part C? Definitely blind, and yeah, Jorge, double blind, right? So for sure blind, but it is double blind. Now, why do we know it's double blind? Because remember, if it's single blind, the participants do not know, which that criteria is met. But along with that, nor do the fitness and nutrition advisors. That last part is telling me that we actually have a double blind experiment, right? And the reason for that is not just the participants, and researchers, we'll just label them, do not know what group they are with. Okay. All right. Okay, does that make sense? Any questions on part C here? Okay. All right. So now let's look at part D. All right, part D states, is this best described as an experiment, a controlled experiment, or a placebo-controlled experiment? I think definitely an experiment, because we choose our groups, we divide them. But now the question is controlled or placebo-controlled. I would say that definitely experiment, definitely controlled, but there's also a placebo involved. That inert pill is the placebo. So I would say a placebo-controlled experiment. It's placebo-controlled because if we look at up here, there is a group that receives an inert pill, right? And what that means, it's a pill that it's essentially just probably some kind of sugar pill where it just kind of dissolves and it doesn't have any medicine, right? So that's what makes it placebo-controlled, right? When we are informing the group that they're taking medicine, but it really doesn't have any type of medicine, right? That's why it's placebo-controlled. Okay, does that make sense, Melody? Okay. All right, any other questions on this particular problem? Number 16 for homework 8. One or two, there are two groups we can label two. One of them is so they're both receiving a pill. One group receives a pill that doesn't do anything. It really just dissolves. There's no medicine in it. And the second group is actually receiving this drug, Garcinia cambogia. Okay, does that make sense, Theodore? So it's modeled that it's exactly the same in that they take this pill, right? Both groups, right? They do the same exercise and diet, but one of those pills is just it's not really anything, any kind of medicine involved in it. Okay. All right. Any other questions on this example here? Okay, so now let's take a look at the next question I was asked here. So we're going to look at homework 8, number 20. Let me bring that one up. Okay. All right, we'll get to number 18 after this one, Melody, okay? All right. So, all right. A sports psychologist believes that people are more likely to be extroverted as adults if they played team sports as children. Describe 2 possible studies to test this theory. Design one as an observational study and the other as an experiment. And then we'll say which is more practical. Okay, so if we look here, we say, okay, that people are more likely. So here is our claim, right? So this psychologist is that people are more likely to be extroverted as adults if they played team sports as children. Okay, so that is the claim here, right? And then it said, all right, we have a claim, so we want to go out and we want to collect data. All right, so, and then it says, well, we can do this. We talked about 2 different ways to do this, right? One in terms of what was called an observational study. So it's and the other was the experiment. So let's look at what it would look like to be an observational study. So if we were to do observational, we would gather, or we would probably, one way to do this would probably be to ask adults if they played team sports as children. Okay, so we go out, we have some kind of random sample of adults, right? We can gather them, kind of survey, go out, survey them online, or some way to just kind of collect data, all right? And then we would ask if they consider themselves extroverted. Okay, so that would be an example of an observational study, right? We're not controlling anything. We just go out and we ask people some questions. We're just observing and collecting data. All right, so that would be an example of if we did this of observational study. Any questions on this part right here? on the observational study. Okay, all right, so that would be a way to do an observational study. So now let's look at what would an experiment look like. All right, so experiment would be, that'd be a little bit different. We'd have two groups. Randomly selected. Now in this case, since we want to have a controlled experiment, we would have to two groups of randomly selected children. All right, and we would make one group play team sports. And then the other group, no team sports. Okay, so notice that there's more control, right? We have the groups as children, then we make one of them play team sports and the other group not play any team sports. All right, and then we would track, however we want to track their progress, their development, and see if they are more likely to be extroverted, however that is measured. Right little meter there. Let me rephrase that and then see which group is more likely to be extroverted. Okay, and then whatever those parameters you want to set up to measure this idea of being extroverted. Okay, so these are an example of an observational versus an experiment. Any questions on kind of the difference between both of these that we have in front of us right now? All right, now let's take a look here at the last part of this question. So we have theoretically a way to do an observational and an experiment. Which is more practical? If we look at what we have to do, what would be, just in terms of resources and time, what would be a more practical approach to this, the observational or the experiment? The experiment, you would think, kind of, how long do you think that experiment would last? If we start when they were children and then we track them till they're adults, okay? That lasts a long time, right? At least 20 years, right? Over 10 years, right? A long time, right? If we think of children to their adults, how long would it take me to do an observational study? Maybe a few days, right? Depending on how many people I can get to take my survey. Now, in terms of practicality, not really what would be the best way, right? A couple days, yeah, right? Practicality and what would be kind of the best approach here, I would say that the more practical way would be an observational study. So I would say, I would kind of make the conclusion that the observational is more practical. Yeah, maybe 2 weeks, right? Definitely not years. Right, in terms of less time and resources. And also maybe ethically, we don't want to force children to do something that they don't want to do, right? I don't know, would it? It might be. I mean, I don't know, 14, but again, right, this is not saying in terms of effectiveness, it's just saying practicality, right? I think if we think of these children as people, it really doesn't make sense to say, all right, we're going to force them to do something and force one group to do another thing, right? It might be, but again, that's not what it's asking us, right? Here we're talking about practicality, all right? Like if you actually wanted to test this, right, would it make sense? How does that work for you, Renee? In terms of practicality, oh, okay, well, good for you. In terms of practicality, I think it's better to do just kind of an observational study. The claim again was from the problem. People are more likely to be extroverted as adults if they play team sports as children. Okay, so let's, any questions on this problem here? Okay. All right, so let's see here. I have a question for number 18. All right, so we're gonna look at again, homework 8, number 18. All right, let me pull that one up. Okay. All right. Okay, so let's look at number 18 here. So it says a study is conducted whether people learn better with spaced or massed practice. Okay, so I assume mass means they're just kind of doing it all bunched up around in a shorter time period, as opposed to space to be a more spaced out, more time, the same amount of practice, I'm assuming. Subjects volunteer from an introductory psychology class. At the beginning of the semester, 12 subjects volunteer and are assigned to the mass practice group. At the end of the semester, 12 subjects volunteer and are assigned to the space practice condition. All right. Okay. Is this a sampling or a census? All right, so just kind of based on, just going off kind of the context here, we have, okay, looking at this. Yeah, I would assume that this is sampling because it doesn't say the whole class, it just says volunteers. All right, so I assume that it would tell me that the whole class was forced to do this, but I would say sampling. I'm assuming that it's not the whole class. Okay. Is this an observational study or an experiment? Well, this looks like this is an experiment. We're asking people to do something, right? All right, we're telling them that this is a routine that you have to implement. Okay. All right, so now let's look at C. This study involves two kinds of non-random sampling. Subjects are not randomly sampled from some specified population.
Again here, and that means that they only looked at this psychology class, right? And then subjects are not randomly assigned, right? So here, two things are going on here, right? Oops. Hold on, no problem with my pen here. All right, this thing is acting up on me. But anyways, let's look at this here, right? So subjects are not randomly sampled from some specified population, right? That means that only this is in this psych class, not in the whole school, right? Just kind of people that are in this psych class. All right, and subjects are not randomly assigned to groups. So part one, so here, part one, we're looking at this psych class. And for part two, we're looking at volunteer. Okay, so it says which problem is more serious and what effect on the results does each have? All right, in terms of serious, let's see here. From an introductory psych class. I would say the more serious would be one, and really just because it's not a representation of the whole population, whatever that population may be. Yeah, due to, again, both of those are biased, right? Here what we're trying to say, right, would be a bigger bias. And I think here, if we just kind of limit ourselves to one group that are in this introductory psych class, that is probably not a good representation of the school itself. And if we're trying to make kind of assumptions about an even bigger population, then that won't be very useful as well, right? And again, the same thing for the volunteer, right? If so, and then for two, I would say here we volunteers are usually people who have a previous interest, or maybe a bias. So maybe they already know they fall into one of those groups and they say, all right, well, let me volunteer into those groups that they are asking for. Okay. All right. Does that make sense, Melody? Or anyone else have any questions on this problem? Okay, so let's kind of go back here. So we're okay with A, B, right? It's just part C that kind of was tripping you up here. Okay. So do we understand the non-random sampling going on here? So if we look at the way this is structured, right? If we look here, this study involves two kinds of non-random sampling, right? So the first kind is that the sample right? So let's say that we wanted to conduct this experiment, right? A way that would eliminate bias to have a more representative would be to have some kind of random sampling of our entire population, right? So let's say just for this particular experiment that the population was whatever school they're in. All right, some kind of university. All right, so what they did is they took a sample. So their sample came from a volunteer, or volunteers, I should say, of an intro psychology class. Okay, so this is the non-random sampling, all right? Do we understand that part, Melanie? The idea that this is the way that they took these samples. Okay, so now the question is, right? What is the question here is, well, why is this non-sampling, right? Why is this a problem? Okay, so the whole school sample volunteers of an intro psych class, right? So the problems here are, it is not representative of the whole school. All right, maybe not everyone in the school takes an intro psychology class, right? And it would have to be for this particular one, right? So now we're kind of excluding a large population of the school, all right? So now we could see why this would cause a problem in our study, all right? Now, does that make sense, Mark? All right. And then the second part, so it's not representative of the whole school. The second problem here is that volunteers make up the sample. Okay, and again, the problem with that is always when you get volunteers, it's always people that might have a bias coming into this. Maybe they have some kind of feeling for one specific way over the other, right? So when we look at this, we say, all right, these are two major problems. And I would say the most serious one is this one here. I would say this one is the most serious, right? And again, here I would just say that's the most serious, since we do want, if we want our random sample to include everyone, or the chance that everyone in the population to be chosen. Right? Does that make a little more sense, Melody? Okay, yeah, no problem. Any other questions here? Any on this problem that we've done? Okay, we do have to move on today and start some new material. So I'm going to bring up Okay. Give me a second here. All right. Okay, there we go. Okay, so you can find these notes on Canvas. Again, well, actually, before we jump into the new stuff here, a reminder here. Let me, here, if we look at Canvas, all right? So a couple things that I've updated over the past few days. Your grades are all updated. For the most part, if you haven't turned anything, except for the stuff that's due today, all right? Now, a couple things here. If you look at modules, okay, so I added a new module here, resources. So again, the mode that you're going to be able to upload or turn in assignments would be via Canvas. And here's a demo of using Adobe Scan to Canvas. You can click on that if you're having trouble using that. It has a nice demo of how to use it. I've started a new module for this week with the standard deviation notes and our homework 10, which will be due a week from today. Okay, so again, right, now that we're meeting this form via Zoom, the best way to keep up to date on everything would go to the modules. That way it has a breakdown of what will happen each week. All right. All right, what's your question, Jorge? Yeah, I'll upload the homework notes, Melanie, once we're done for today. Okay, so why don't we go over that now then, if we're looking at project 3. So let's take a look at, okay, so if we look here, we have project 3. All right. So this is, again, this is all uploaded on on Canvas, and I'll actually add it to one of the modules. And the due date for this, all right, so this due date, so statistic project, it'll be due 4/22. All right, so in roughly about a little bit more than 3 weeks, 3 weeks from Wednesday. All right, so the assignment is going to consist of determine 2 questions of interest, right? These 2 questions are any questions that you want to ask, right? So you're going to be taking a survey. All right, you're going to survey, says at least 30 people. All right, now, one way that you can do this is through a Google form. All right, so you can set up, since we are doing social distancing, it's going to be, usually I would say you can just go out on campus and start asking people, but that's not going to be a possibility here. So here's my suggestion to you to do this, right? One question should be, so first of all, just kind of the technical stuff. One question should be qualitative, and the other question should be quantitative, all right? So once you formulate these, make sure that those are, that you do have a quantitative and a qualitative. If you are unsure, right, maybe go over your notes, what quantitative and qualitative means. And if you have these questions and you still want to make sure you have proper questions, let me look at your questions and I will tell you that these are good to go or that you still need to kind of rephrase them different. All right. Now take a random sample of at least 30 people. So one way to do this is once you are completed with once you set up your Google form. Now I say Google form, this is the best way. It collects the data for you. So once it collects the results, it'll save them for you. And again, I'll post a link kind of how to set up a Google form or kind of demo it so you can kind of get an idea of what the Google form should look like, right? You can ask family members. You can text your friends and be like, hey, can you, now it doesn't have to be a Google form. You can just text your friends and say, all right, can you answer these 2 questions, all right? And I think through family, this class, that should get you to about 30 people, all right? Now, the sample, it doesn't have to be students, right? It could be just people you know, right? So that's all that is required there. All right, you take a random sample, all right, and again, guidelines, be sure to ask your question consistently, all right? You can create an online survey. I recommend using the Google form, so there's a link to that, and because it's nice, it compiles the responses for you. And then from there, so the first part, collect the data. Next part is do some describing data like we did in the week before spring break. A frequency distribution or a histogram. For each data set, construct a statistical graph. So there should be a frequency distribution for each question. So 2 in total. Frequency distribution, think of a chart of some kind. And then from there, you do some kind of a graph, right? And again, as always, make sure to title your graph, do all that stuff, and then 5-number summary and standard deviation, which we'll go over today. So hopefully that'll make more sense. And then ask 4 non-trivial questions, 2 per topic question. Now, these non-trivial, what I would use as kind of a guideline for this is look at our homework questions, how they're phrased, and try to see if you can ask similar homework questions based on your statistical information that you've gathered, all the information that you've gathered for your project. All right. Okay, is there any kind of general questions on the project here? Or 3 and 4, you could use software, Excel, Google Sheets, or you can do them by hand. That would be equally as useful for those, right? Well, if you know how to use Excel, or you want to kind of do a little just kind of Googling, I think the simplest way is really Excel. It generates some nice pretty graphs for you, or Google Sheets. I think that would be and it's a good kind of a skill to have to kind of get an idea of how to use Excel. I would suggest kind of getting acquainted with that if you are not already. Okay, any other questions on the project? Okay, so maybe as you begin working on this, and I would definitely at least today start kind of thinking of types of questions you might ask and try to formulate those. 30 points, same as our other projects. And again, right, the important part here is not just the points, but the weight of the total projects. Right, I think, and you can find that. I don't remember off the top of my head. You can find the weight of all the projects on the syllabus. Okay. Now again, what you notice, these projects are made, you can do them on your own time, right? If you haven't done well on the exams, these are a way to kind of help boost your grades. So I would kind of focus your energy and try to do really well on this project. Okay. All right. Any other questions here on this? On our project? I don't know just now at this point. We still have 1 exam and our final. I'm still trying to figure out how that's going to work. Okay. All right. I will keep you informed as to kind of what that would be moving forward. But as of now, we'll probably be doing this. Well, at least it seems like for all of April, but most likely, well, I don't even want to say. I don't know. Not as an email. The same way we're submitting the assignment. It's like as far as Canvas is concerned, this is just another assignment, like a homework assignment. So you would submit it the same way there, right? If you are not sure how to do that, I would look at the demo that I posted. So you can take a look at how Canvas and Adobe Scan kind of work together. And that's exactly what I want you to do for your homework and the project. There will be changes, probably the date of it. And again, things are a little fluid right now. I am still not sure yet. I will keep you guys updated as to when that would be and how it would be, the form of exam 2 would be. Okay. Yeah, April 20th. Maybe again, I still have to figure out how we would do that if we're not meeting in person. All right, but that is our scheduled, that is our date for right now, but that is subject to change. All right. Okay, any other questions so far? All right, thank you. I know it's a very confusing time, just kind of trying to figure this out. Thanks for your patience, and I'll try to keep you guys updated as things change. Okay, so now let's try to get through, well, at least start our standard deviation kind of topic here. So if you look at here our notes here, again, you can find a copy of these on Canvas. So previously, right, we started off kind of describing data as a visual representation, right? And now and then after that, we talked about kind of numerical representations, right? We looked at, so before, right, we had mean, median, and mode. Right? So those were kind of numerical representations, and those seem like, all right, those are good ways to describe the data, but in some cases, those aren't, they're not enough, right? They don't really tell the whole story, right? So we have a few kind of definitions here, but I'm going to refer to them as we kind of work our way here, right? So why do we need more than just the mean, median, and mode? Well, let's take a look at this example here. So if we look at our example, it says, consider these 3 sets of quiz scores, right? So we have section A, section B, section C, right? So those have completely different scores, right? Now, if we think of the previous ways that we did with our numerical data, if we look at section A, and I wanted to calculate the mean and the median, right? So again, mean, I add those all up, and it looks like we have, what, 1, 2, 3, 10. So there's 10 of them, so I add them all up, I divide by 10, and they're all the same number. So what we're gonna get is, the mean is 5, right? And the median is actually also 5. Right? Again, we just look at the one in the middle. For even numbers, we add the 2 in the middle, and then we divide by 2. So in both cases, those are 5. All right. Okay. Now, if I look at section B and I perform the same operations, right? As it turns out, the mean and the median are also both 5. Right. And if we take a look at section C, and you can probably guess where this is going, the mean and the median, they're also both 5 and 5. All right. So now we could see kind of at a glance, we would say, oh, those are the same set of data, right? If all we're given was this summary, right? Where we had the summary was mean and median. So it would just be 5. But if we dig a little further, we say, well, those look completely different. So we need a different way to or we need more besides the mean and the median, right? Does that make sense at this point? Any questions? That's kind of what we got going so far. Okay. Jorge, section B, a question on that part, on section B. Oh, okay. So we just add, so there's 10 scores. So we add 1, 2, 3, 4, 5. The rest are 0, and then divide by 10. So 50 divided by 10 is 5. And the median, again, when we're dealing with even numbers, these two are the ones in the middle, right? So we add those, 10 plus 0 is 10, divide by 2 and you get 5, right? So the median is also 5 for that. Okay, and I did the same thing for A and C, right? We just did it the same way. Right? Okay, so now we could see that we need more to describe the data. All right, I would like to capture the fact that these are not the same, even though the mean and the median tell me that they are based on that summary. Well, I need other pieces of information. All right, and that's where some of these other terms come into play. Right, the first one is the range, is the difference between the maximum value and the minimum value of the data set. Right, so if we look, okay, so if we look at the example down here, let's calculate the range. For section A, the range would be largest value is 5, smallest value also 5. So we get 0. All right. Section B, the largest value is 10, the smallest value is 0. So the range is 10. And now we start to see, all right, along with the mean and median, the range, now that's giving me more information, right? And that's all the purpose of these extra statistics are, right? We just want more information, right? Because we see that the mean and median are not enough to describe every single data set, all right? And if we look at section C, the largest value is 6. The smallest value is 4. So that is equal to 2. Okay, and now we start to see, all right, now we start to see the difference in those data sets, right? A, B, and C, right, by calculating the range. Okay, any questions on the range? Melody, what is your question? Well, the range is always the largest value minus the smallest value. So the largest value is 10 and the smallest value is 0. Right, so 10 minus 0 is 10, right? Remember, those are 0 scores. We have 5 people scored a 0 on this particular quiz. Okay. All right, any other questions so far we got here? So we're okay on calculating the range, or what is the range, more importantly? Okay. All right. So now our next term is this idea of the standard deviation. Okay, so the standard deviation is a measure of all this means, so it's a measure of variation based on measuring how far each data value deviates or is different from the mean, right? If we think of our mean as kind of the center of our data, we want to figure out, well, how far spread out is it, right? Is there a lot of spread, right? That would correspond to a higher standard deviation. Are they all bunched up in the middle, right? So here, if we take a look at our quiz score, right? So for the first one here, for section A, right, there's no deviation, right? All of them are 5, right? So we would have a standard deviation to be 0, right? And I'll do actually a separate example where we go through a in-depth calculation of standard deviation, right? And then we'll look at how the calculator is actually gonna help us out so we don't have to do all these kind of calculations over and over again, all right? But we're just looking at kind of guessing what the standard deviation is. We look at B, there we have a widespread, right? If 5 is kind of our mean, well, we have values that are at 0 and then at 10. So that's gonna give me a rather large, again, kind of relative large standard deviation, right? And this one has 0 standard deviation, right? Because all the values are the same, right? Now, for section C, those are more bunched up, right? If we look at the values, they go, there's 4, 5, and 6, right? So there is deviation, but it's very small, right? So here, relative small standard deviation. Okay. All right. So if we want to kind of think of what is standard deviation, just think of it's the measure of how spread out the data is. The higher the standard deviation, the more spread out it is, right? And one thing that'll be clear when we do the calculations is the standard deviation is always positive. The standard deviation will be 0 if all the data values are equal, and will get larger as the data spreads out, all right? Okay, so standard deviation has the same units as the original data. So here, quiz scores, standard deviation is in terms of quiz scores. And standard deviation, like the mean, can be highly influenced by outliers, right? So there are some outliers that will make the standard deviation be higher, right? Regardless of in what direction the outlier is, since it is always a standard deviation, it's always going to be positive. Okay. Any questions so far before we jump into kind of a calculation of standard deviation? Okay, so let's take a look at the procedure to compute standard deviation. So to find the deviation of each data from the mean, in other words, subtract the mean from the data value. Okay, 2 square each deviation, 3 add the square deviations, and then divide by n. All right, so let's actually kind of work through it so we can kind of see at each step of the way what those calculations are. All right, so looking at this, I'm going to set up a table here. And I'm going to have All right, so here I'm just kind of setting up my table here. Okay. All right, so in the first column, I'm going to label that column X, and X is going to represent my data values. In this case, the price of the peanut butter jars. So 329, 359, 379, 375, and 399. Okay. All right, and let's, we did the example here before to calculate the mean. And let's just do that one real quick here. So I'm going to add up all these prices. 329 plus 359 plus 379 plus 375 plus 399. And I'll divide that by, there's 5 of them, so 5. So the X bar here is 368. All right. Okay, so far, stuff that we've done before, right? Just calculating the mean. All right, so here, that is the mean. All right. Okay, so now that is, let's take a look at the first part of our procedure. It says, find the deviation of each data from the mean. In other words, subtract the mean from the data value. So here, we're going to do that calculation, right? X minus X bar, right? So in this case here, we're doing 329 minus 368. Right, and that gives me negative 0.39. Okay. All right, now again, it's negative because 329 is to the left of the mean, right? And now continuing on, we'll do 359 minus 368. And we get negative 0.09. And again, continuing here, 379 minus 368, we get, notice here that one is positive, right? So, and that is because it's on the right of the mean, right? It's bigger than the mean, right? Notice none of these are actually equal to the mean, which is not uncommon, right? That the mean actually is not necessarily a data value. So now let's look at 375. And that is 0.07. All right, and then 399 minus 3.68, and that gives me 0.31. Okay. All right. Any questions so far? So we've done part 1. Okay. All right, so now let's take a look at part 2. It says square each deviation. So we're going to take X minus X bar, and we're going to square it. Okay, so we'll take 0.39, negative 0.39, square it, and we get 0.1521. Then 0.09 squared, 0.0081, and then 0.11 squared, 0.0121, and then 0.07 squared, 0.0049, and then lastly 0.31 squared, we get 0.0961. We'll get to that in S sub x. What are you referring to, Melody? I know, but this notation S sub x, is this like, are you talking about in terms of the calculator? I'll get to the calculator. I'll get to that after we do the kind of the manual calculation, and then we'll take a look at the calculator version of how to do this. Okay, so for now we're just doing this, computing this by hand, and then hopefully you'll see, all right, well this seems rather tedious, and I'm much rather learn how to use a calculator to, especially if we have, let's say, 10 data values, right? How that would be a much more effective way to calculate this. All right, so far I completed step 2, square each deviation. So I've done that, okay? And now let's say add the square deviation. So I'm going to add them right here. Okay, so if I add all of those together, so we get 0.5210081 plus 0.0121 plus 0.0049 plus 0.0961. All right, and that gives me a grand total of 0.2733. Okay, all right, so that covers part 3. Now, let's look at part 4. So it says divide by n the number of data value if the data represents the whole population, and divide by n minus 1 if the data value is from a sample. All right, the reason, there's a lot of kind of math technical reasons for this. One way to just think of this is since it is a sample, right, there's more kind of bias in our calculations. So instead of dividing by n, we divide by a smaller number, which kind of increases the standard deviation. So that's the reason for the n minus 1. So let's take a look here. For our case, for step 4, we want to take 0.2733, and I want to divide that by 1, 2, 3, 4, 5. And I assume that there are more than 5 brands of peanut butter, so I'm going to say that that's going to be a sample. So I'll take 5 and I'll subtract it by 1. So the calculation that I'll perform is divided by 4. And plugging that into my calculator, 2733 divided by 4, we get 0.0683. All right, and I'll round to that 4th decimal place. All right, and then lastly, in step 5, so the standard deviation, so we'll call it S for now, is the square root of that number. So the standard deviation is 0.26, right? And again, this is the same value, or excuse me, the same units as our data value, so 0.26 cents. So 26 cents is our variation. Yes, Jorge, we divide by 4 since I'm making the assumption that this is a sample of peanut butter jars at a store. So n is the number of data values. In this case, counting them all up, we have 1, 2, 3, 5 data values. So we just subtract it by 1. All right. Okay, any questions so far on this example here? Okay, so this is a way to do this by hand here. just kind of the long way, and we see it's kind of tedious. So what we're going to do, and not today, this will kind of conclude our lesson for today. What we're going to do next time is we're going to say, all right, how can I use the calculator features the same way that we did the mean and the median by using the list to actually just arrive at this conclusion like we did here by doing the calculations by hand. All right, so why don't we stop here for today, and then we'll continue this on Wednesday. All right, again, we have homework due today. Please make sure that you upload them via Canvas. Make sure that you are able to do that. If you are not, please reach out to me and let me know so we can hopefully guide you through it, or take a look at the demo that is posted there, that quick little video to kind of help you. All right, and you take care as well, Renee. All right. All right, have a good day, guys.